All right, my iPad's been doing some weird stuff, so unfortunately I'm making another video because the example 3 was disappeared off my screen here. So again, let's go through and do 324 times 15. And so again, we're going to do expanded notation, which we did last time, and then we're going to do instructional, which we haven't done yet, and then a final standard, which again is the same thing we've been doing for a long time. So again, with this one, we want to do expanded, but now since we've got a two-digit number, 15, instead of a single-digit number, we're going to have to actually expand it also. So in this case, we're going to look at 300 plus 20 plus 4 and 10 plus 5. So what you're going to do, and probably the cleanest way to do this is sort of think of these as two separate problems. Think about multiplying 5 times everything, multiply 10 by everything, and then just kind of combine them at the end. So in this case, I'm going to write and go ahead and do this multiplication first. So the good thing is, since we're just multiplying by 10, all we're going to do is just add zeros on to everything. And then now do the same thing with 5. So I'm going to actually do it up here at the moment, so that way I can show you how I'll add these up in a second. So 5 times 300 would be 1500. 5 times 20 would be 100. 5 times 4 is 20. And now let's go ahead and line these guys up underneath. So we'll put the 1500 down with the 3000, line the 100 up with the 200, and line the 20 up with the 40. And so now we can just add these guys up and down. So in this case, we've got 4500 plus 300 plus 60. And so this is kind of the nice thing about this expanded notation. There's so many zeros running around that we're really not adding much more than a single digit number to another single digit number, or we're not multiplying anything more than a single digit number by a single digit number. So that's one of the things that's kind of nice about this. So now if we add these guys together, we're going to get 4800 plus 60. So we end up with 4860 in this case. All right, so instructional, what we're doing is really kind of a modified version of the expanded notation, except we're kind of writing it in this chart form. So what we're going to do is, since in this case I've got 2 rows, I'm going to write the rows as basically the expanded form for 15. So I'm going to put 10 at the top, 5 at the bottom. And then I'm going to do the same thing across the top. So 300 plus 20 plus 4. And then what I'm going to do is I'm going to use these as a way to multiply each other. So like in this case, 300 times 10 is going to give me the answer that goes in that spot. 20 times 10 is going to give me the answer that goes in that spot. And then 4 times 10 is going to give me the answer that goes in that spot. So again, since we're just multiplying by 10, all we're going to do is just add a 0 to everything. And so now do the same thing for 5. So I'm going to take the 300 times the 5, and that's going to give me that spot. 20 times the 5 is going to give me that spot. And then 4 times the 5 is going to give me that spot. So 300 times 5 is 1500. 5 times 20 is 100. 5 times 4 is 20. And so again, just like we did before, I'm just going to kind of add these guys up and down. So 3000 plus 1500 is 4500. Plus 200 plus 100 is 300. Plus 40 and 20 is 60. So again, add these guys together. We get 4800 plus 60 equals same thing, 4860. So good, we did a good job on that. All right, so finally, the final standard would be just doing 324 times 15. And so again, we're going to do 5 times 4 is 20, carry the 2. 5 times 2 is 10, plus 2 is 12. 5 times 3 is 15, plus 1 is 16. And then now we're going to put a 0 there just to kind of remind us that we need to scoot everything over by 1 because we're multiplying by the tens. So our first number has to go in the tens position. So 1 times 4 is 4. 1 times 2 is 2. 1 times 3 is 3. And so again, add up and down, we get 4, 6, 8, 4. So luckily, all 3 of them were the same, so we must have done it right. So good job. All right. So now let's look at division. So for division, there's only 4 possible things that we're going to look at. We're going to look at what's called repeated subtraction. So again, it's kind of the opposite of repeated addition. Scaffolding, which is pretty close to the standard division, but you'll see it kind of organizes things in a nice way. So we'll look at that. Standard is just probably what you're used to when it comes to division. And then short division is sort of a weird thing, but I'll show you how to do it anyway. I don't know how often you'd ever use it, but it's interesting. So repeated subtraction. So the way we're actually thinking about this, so in this case we're dividing 835 by 6. So what we're going to do is kind of tally, like, how many 600s could we subtract? How many 60s could we subtract? How many 6s could we subtract to get our answer? And you really could just go through and actually do it that way, like actually subtract 100 as many times as you could, just to, and then see how many 600s it makes. And the reason I'm using 600 is because we're dividing by 6. So if we were doing divided by 5, then I would see how many 500s I could subtract, how many 50s I could subtract, see how many 5s I could subtract. So it's always going to be that number times 100, that number times 10, that number times the ones in this case. So in this case, off to the side, I'm going to write down 600s. And so how many 600s can I subtract from 800? It's just going to be 1. So I'm going to go and write the 600s there. So if I subtract that, I get 5, 3, 2. And so now I'm asking how many 60s can I actually subtract away? And so worst case, if you didn't know, you could just physically go through and just keep subtracting 60 until you ended up with something that was smaller than 60. So I just happened to notice that I can subtract 3 60s away, which is the same thing as 180. So in this case, I get a 5. 13 minus 8 is 5. So again, I got 55, which is less than 60. So that means I did a good job. So now I'm trying to see how many 6s can I subtract away. And so in this case, it looks like 9. That gives me 54 with a remainder of 1 in this case. So I've got a remainder of 1 left over. So my answer is to kind of line these guys up. So in this case, 139 with a remainder of 1 in this case. And so again, I'm lining them up because this was 1 was in my hundreds position, the 3 was in my tens, the 9 was in my ones. So that's how I want to line those guys up. All right. Everybody okay for repeated subtraction? All right. So scaffolding, again, we're going to set this up so it looks like a regular division, but what you want to do is leave some room at the top in this case. So instead of writing the division up at the top like this, I'm going to write it kind of in the middle of the paper. And so what we're doing is we're sort of similar to the way we're doing repeated subtraction. I'm trying to figure out how many, 600s or how many 100s go in first. So instead of just kind of looking at the 8, I'm kind of looking at this as just 800 and kind of ignoring the 35 for the second and saying, how many 100s will go in or 600s will go into this 800. So in this case, I know I'm going to get a 1, but instead of doing a 1 like we would do with the standard model, I actually write out the 100 in this case. And then 100 times 6 gives me 600. and then that gives me 235. So now do the same thing. I'm trying to figure out how many 60s go into 235. And so I think we saw before that it was 30 in this case, or 3. So I can multiply 30 times 6 to get the 180. And then finally, how many 6s go into 55 would be 9. So again, 54 minus 1 gives me a remainder of 1. And now I just kind of add these guys up and down. So if I add them, I get 139 with a remainder of 1. So again, it's pretty close to the standard division algorithm. Like I said, the only difference is instead of just kind of carrying one number along, you're thinking about it in terms of how many hundreds, how many tens, how many ones, and actually kind of writing that number down as we go along. But all right, so let's do standard real quick. So again, since we probably know how to do this anyway, so in this case 6 goes into 8 one time, bring down the 2, and bring down the 3. 6 goes into 23 3 times. So bring down the 5, bring down this other 5. 6 goes into 9 54 times. And then again, remainder of 1. So we can just kind of write that up there. And so the good thing is we're getting the same answer every time, so that's nice. And so finally, the last thing is what's called short division. And so what this does is it really just breaks this problem up into a bunch of smaller problems. So instead of like dividing the whole 835, what we do is we first take 6 and divide it by 8. Now, if the number that was the first number, if 6 didn't go into it, like for example, if it were a 1, then we'd have to grab the first 2 numbers. But in this case, since 6 does divide into 8, we just need to grab that first number and that's all. So now we know 6 goes into 8 one time, and that gives us a 6. So bring down the 2. So now what happens is this 2 from our remainder becomes the first digit in our next division, and then the 3 comes down next. So whatever the second digit would be goes right after it. So now we're trying to see how many times does 6 divide into 23. So again, that's going to be 18. So minus 18 gives us a 5. So just like before, the 5 is going to be the first digit of our new division. And then we bring down the last 5 in this case. And so again, we're dividing by 5. So 6 doesn't go into 5, but 6 goes into 55 9 times. And so that leaves us a 1. And if there were more numbers, we would just keep repeating this over and over and over. But since this is our last number, that's just going to be our final remainder in this case. And now we just line these numbers up kind of in the order that they're in. So 139. Oops. Remainder 1. Ugh. It's not iPad problems, it's me problems. Jeez. All right. So that's it for all 4 division algorithms. So again, 2 out of the 3 are pretty similar, or 2 out of the 4 are pretty similar to standard. Short division, again, is kind of similar to standard, just a little bit of a twist. You just have to remember to kind of keep carrying that remainder over. And then repeated subtraction is probably the trickiest just because it's kind of odd looking. It's probably not something that you're used to doing, even though I think it's kind of a neat way to represent what we're doing. But if you have any questions, there's a bunch of practice problems on here for you guys to work on. So if you have any questions, just let me know. Otherwise, I will see you guys tomorrow. Good job.